Hey there, focus learners, and welcome. Today, we're unpacking something absolutely huge in the healthcare space: the massive shift away from one-size-fits-all diets to the incredibly cutting-edge world of AI-driven precision nutrition. Over the next few minutes of this explainer, we're going to separate the actual clinical reality from all that technological hype you keep hearing about. I promise you, by the end of this, you are going to look at your daily meals in a completely different light. Okay, let's dive right into this. Here's our roadmap for today. We'll be zooming from global tech down to cellular biology and back out again, covering 1. The end of average, 2. The AI nutrition toolkit, 3. Decoding your DNA blueprint, 4. The reality of clinical AI, and finally, 5. The future of augmented care. All right, part 1, the end of average, moving beyond one size fits all. Look, we've all been there, right? You get this generic advice like just eat less fat. And it's incredibly frustrating because it doesn't seem to work for you. Well, those rules were historically designed to prevent basic, population-wide nutrient deficiencies. They were absolutely not built to optimize your specific health. When we put these two concepts side by side, the contrast is just stark. Traditional nutrition is broad, population-wide, and rooted in preventing historical food scarcity. But personalized nutrition, that is highly individualized, it's driven by your unique genomics, and it's heavily focused on preventing modern chronic diseases like obesity and diabetes. It's an entirely different target. Now, what's really interesting here is how exactly this fundamental shift is playing out. We are finally moving away from generalized recommendations that rely on really flawed memory-based dietary assessments, trying to remember what you ate last Tuesday. Instead, we are leveraging advanced bioinformatics to create highly predictive models. These models actually map your specific genetic variability directly to tailored dietary advice. And the result? Not only does it yield better clinical outcomes, but it significantly enhances our ability to actually stick to the diet in the first place. Moving on to part 2, the AI nutrition toolkit, how technology tracks what we eat. Let's actually break down the tools making this shift possible, because this is where the tech magic meets reality. Machine learning, brilliant at finding hidden patterns for metabolic prediction, but it's highly vulnerable to training bias. Deep learning, it drastically reduces human error by automatically recognizing food images, but the second you step outside its database, it fails. Natural language processing can give you 24/7 coaching, which is great, but it has a real risk of hallucinations, giving you totally made-up facts. And generative AI can rapidly predict healthy flavor combinations, but it totally lacks real-world consumer validation. So we're looking at incredible, unprecedented power, but it's paired with critical limitations across the board. Let's see one of these deep learning workflows in action. Imagine you snap a quick photo of your plate. The first neural network filter jumps in, recognizes the food, and estimates the volume. Then, a second filter matches that to a nutrient database, giving you real-time macronutrient outputs. And honestly, it is amazing at estimating volume, but it hits a massive wall with mixed meals. It simply can't deconstruct a complex blended dish, and it really suffers from occlusions. It absolutely cannot account for hidden ingredients. If there's a massive chunk of butter completely hidden inside your rice, the algorithm isn't going to know it's there. But it's not all just smartphone apps for tracking our lunches. Machine learning is actually tackling massive, global infrastructural challenges right now. In resource-limited, underserved regions across the globe, there's a severe lack of trained healthcare personnel. But by deploying offline mobile platforms that process easily accessible basic parameters, like demographics and simple surveys, AI models can accurately predict malnutrition risks on the spot. This triggers early intervention and drastically reduces the burden on fragile health systems. It is literally a game changer for global health capability. Which brings us to part 3, decoding your DNA blueprint, the biology of who we are. Before we go deeper, let's just lock in 2 foundational biological terms. First up is multiomics. This is basically the combined analysis of your genome, your proteome, and your metabolome. It's the whole biological picture of you. The second term is SNP, or single nucleotide variant. This is a tiny, single genetic variation in your DNA sequence, but it can completely alter your specific metabolic pathways. Keep these in mind. And this brilliantly illustrates exactly why a single genetic tweak matters so much. Take a look at the SGK1 variant. If you have the standard genotype, a typical nutrient intake just flows right through a normal metabolic response, no problem. But if you have an altered genotype, specifically the SGK1 variant risk alleles, your pathway completely diverges. When folks with this variant consume a high-salt diet, they exhibit significantly increased systolic blood pressure, and that effect is totally absent in people with a standard genotype. which means giving a generic low-salt guideline is completely insufficient for this specific group. Their unique biology demands a targeted intervention. Now, think of this multi-omics funnel as the ultimate filtering system for how your body processes fuel. Dietary inputs pour into the very top. First, they hit transcriptomics, which maps how those nutrients literally switch your genes on or off. Then we drop down a layer to proteomics, exploring the structural proteins your cells produce in response. Finally, metabolomics zeroes in on the distinct chemical imprints, the small molecule metabolites that act as the final cellular output. The result at the very bottom of the funnel? Your individual phenotype, your final observable health status. So let's see how this all builds into a continuous cycle, because this isn't just a one-time test. It's the iterative precision life cycle. Step 1, we get your genomic blueprint through a simple DNA sample. Step 2, data synthesis, where we combine that static genetic data with your ongoing lifestyle markers. Step 3, targeted implementation, which gives you a highly personalized meal plan based entirely on that data. And finally, Step 4, real-time monitoring, using wearables to assess your actual metabolic outcomes day to day. And the best part? That monitoring feeds right back into the loop to constantly adjust your diet. It's a truly dynamic, living system. All right, part 4, the reality of clinical AI, confronting limitations and bias. Okay, time for a grounded reality check. To understand what's genuinely viable in a doctor's office today, we have to trace the evolution of the clinical evidence. Down at phase 1, we have abundant proof of concept and usability pilots, lots of apps where users are saying, hey, this is super engaging. Moving up to phase 2, we are seeing emerging validation against ground truth, where computer vision is getting moderate agreement with human dietitians. But at the very top, phase 3, the gold standard randomized controlled trials proving actual long-term clinical change. Those are still really scarce, though they are promising. So we have a ton of hype right now, but the rigorous long-term proof is still climbing that pyramid. We also absolutely have to talk about data imbalance. Right now, there is a massive, heavy weighting toward Western high-income data sets. Models are being trained almost exclusively on Western food logs and cultural diets. On the flip side, low and middle-income countries, along with traditional indigenous diets, are severely underrepresented. Analytically speaking, this is a real problem. If we deploy these Western-trained models globally, they risk completely misunderstanding cultural meals and providing medically inappropriate dietary recommendations simply because the baseline data just isn't there yet. Remember, the output is strictly tied to the input. So what exactly can an AI safely do in a clinical setting? When you put a generative AI avatar up against a real human clinician, the dividing line is actually super clear. The AI is perfect for 24/7 availability, rapid caloric estimation, and general healthy eating advice. It acts as an incredibly accessible baseline educator. But where does it completely fall short? Management of complex comorbidities, providing psychological counseling, and ensuring medically safe guidance with consistent sourcing. Those things require a human. The AI operates best as a primer, definitely not the primary diagnostician. And finally, part 5, the future of augmented care, synthesis of human and machine. I really want you to remember this phrase, augmentation, not replacement. A lot of the early tech hype suggested AI would automate clinical judgment and replace dietitians entirely. That is the myth of replacement. The true clinical paradigm shift happening right now is the reality of task shifting. All the evidence mandates a collaborative model. AI acts as a high-capacity assistant. It handles the routine, automated assessment and tracking, which frees up the human clinician to focus on what humans do best: complex, nuanced, deeply empathetic care. So the crucial point is how this beautiful loop of collaborative care actually works in practice. On the left side, you have the AI domain handling all that routine tracking and data synthesis at a massive scale. On the right, the human domain handles the clinical interpretation, the complex judgment, and the behavioral counseling, the empathy that is absolutely required for lasting lifestyle change. And right there in the center is the patient, empowered by scalable tech, but safely guided and contextualized by human clinical judgment. This is the workflow of the future, folks. To really summarize the definitive reality of modern clinics, I absolutely love this punchy quote from our sources. AI will not replace dietitians, but dietitians who use AI will replace those who do not. The future requires digital fluency right alongside clinical expertise. The professionals who embrace this high-capacity AI assistant are the ones who are going to define the future of care. And as we zoom all the way back out to public health strategy, you can see the ultimate goal here. This isn't just about some individual luxury for folks who can afford genetic testing. By combining an individual's genetic blueprint with AI-driven predictive models, we can identify shared metabolic characteristics across huge groups of people, a concept called metabioping. The ultimate strategy is integrating these precision tools directly into public health frameworks to permanently elevate global diet quality at scale. We are literally looking at a system that could finally manage and potentially reverse the global chronic disease epidemic. Our sources clearly show that precision nutrition is no longer just about reading our genes, it's about actively writing a healthier future. So, I'll leave you with this final provocative thought. With these tools evolving from simple calorie trackers into predictive, highly personalized engines, are you ready to let AI help write your healthier future? Thank you so much for joining me on this explainer. Stay curious, stay focused, and I'll catch you next time.